Section 11.7 puts it all together. We're going to have a bunch of problems mixed up from each of the previous sections on testing for divergence. All we care about is whether or not a series converges or diverges, and the idea is we're going to try to identify the form that would get us the answer the quickest. So a couple of things to look for. We'll go down the list. First one is the test for divergence. If our a sub n term doesn't go to 0 as n approaches infinity, then that's a pretty easy test to see that it's a divergent series. Next is to think about what a p-series looks like and try to identify p-series. Those are very common in this section, and that is 1 over n to the power. After that, look for geometric series. That is a r to the nth power, and of course you have to know in p-series and geometric series which conditions need to be met in order for it to be convergent or divergent. Then we have something that could be compared to a p-series or geometric series, perhaps using a sum or a difference where we can use a comparison. There's the comparison test and there's the limit comparison test. Those are two different types of tests, but they will both get you the same type of answer with p-series and geometric series. Next, we've got alternating series. If it meets the conditions, it's convergent. If it's not exactly alternating, but there are some negative signs that you have to deal with, perhaps absolute convergence would be something to try there. Next, it's factorials and powers of n. It's a good indication of using the ratio test. If you've got powers of n, you might also try the root test. Notice that if the ratio test is inconclusive, then the root test will also be inconclusive, and vice versa. And then the last test is look for convenient integrals, and don't forget to write them as improper integrals and use your limits there. So in the next video, I'll just go through some problems, look and see what I see, and tell you which test I would try first.